Hello, my name is Jeff Soshman, and I'm welcoming you to the first Netflix tutorial where we'll teach you how to run basic simulations. Hopefully you've seen the first introductory video that tells you what Netflix is all about, but if you haven't, Netflix is a software package for running simulations of biological networks without requiring programming experience. For those that do, though, it enables them to do more powerful calculations. And so in this first tutorial, we're going to be teaching you how to do just the very basics of Netflix so that to get you started. I showed this slide in the last video, but to remind you, one of the things that Netflix allows you to do is to start with a little simple network like here. We're going to be using this a lot in these tutorial videos called our example network. You take this visual representation that you may have made before in some sort of cartoon at the end of your paper and format it in Excel spreadsheets using this sort of syntax. But this shows you that there's an input into A, there's input into B, that A can activate C, B can activate D, E can activate C in this positive feedback loop. And then something interesting here, this is what we call an AND gate, where C and not D lead to E, where if D is on, then that would block the activation of D. A couple other things to note is these are what are called reaction parameters. And so the reaction weight defines how strong that reaction is. So for right now, we're showing that the inputs for A and B are off, and the other reactions right here can be fully activated. And this tells us about the cooperativity and sort of the left-right shift of the sigmoidal activation curve that we talked about. So the basic layout in Netflix is that we have a simulation pane that tells us how long we want to run a simulation for, how big the time step should be, which species you want to plot. And this shows you click these buttons in order to simulate the network or reset the network. Down here with the status pane, and it tells you what's going on with Netflix. And then here, you can modify the different reaction or species parameters. As I already showed you the reaction parameters up above. And then we also have species parameters such as the tau is like the time constant for how fast something can change, or the Y max is the maximal expression level of a given species. So that gives us a quick overview. So what we're going to do here is we're going to run through these exercise 1 basics. And I actually really encourage you to try to do these exercises before progressing with the video further to see how far you can get. And that actually kind of heightens your awareness of what things you get or don't get. Okay, so then the next thing I want to show you is how to open up Netflix. So if you install it on Windows or Mac, there should be an icon that looks like this somewhere. And then you double click that, and Netflix will come up. And so here you should see the same sort of panes that we just described. On the right, we'll be showing plots of the simulation. And on the top are menu items for selecting different things. So what we're going to do is we're going to go to the File menu and open that example network. So you're going to want to find where you installed Netflix. And so I just made a little tag to that to make this a little bit faster. Go into the Netflix directory and then to the models directory. And so here you'll find ExampleNet along with 4 of our published larger network models that you can play with. Let's just look at ExampleNet first. So it tells us that it loaded and tells us that there are 5 different species right here. And now, if you look at the inputs, the input reaction weight for A is 0, and input reaction weight for B is also 0. That's good. We want to start off with a steady state resting simulation. That's like when your cells are just sitting there unstimulated in a dish. And then we'll hit simulate. And so this is a very boring simulation. One thing here, this is only showing what's happening with A. If you select the rest of these and hit plot, it shows what all 5 species are doing, which is nothing. But if we go to reaction 2 here and set the weight of that reaction to 1 and hit simulate, you can concatenate various different simulations. You get different stages. And so now this is showing how the response of the network with A, C, and E are getting turned on when we added A. So congratulations, you just ran your first little simulation. You can do even more complicated simulations than that. So for example, if we simulate just a little bit more to let that go to steady state, Now we can simulate what happens if we take A off. So if we take the reaction weight back down to 0 and simulate, you can see something really interesting here, which is that E stayed on while A and C went back down. And so let's take a look at this network structure right here. And so what you can see here is that's also what happened in our published figure right here, where E stays on because of this positive feedback loop going on. So now we can try something different. We can stimulate with B. Okay, and we stimulate with that. There's not so much that happens. Oh wait, I'm sorry. I need to turn on B. There we go. I hit click a couple more times, and so we get a switching of the network that was able to shut down the activation of B. And then if we take that back off, like that. And then finally, what happens if we stimulate both A and B together? Yeah, so you get this kind of really interesting little transient like this. Okay, so that's an example of, let me change these windows a little bit. Okay, kind of a more complex sort of experiment that you might want to do. So if you ran a simulation like this, and there are a couple things you could do. One is that you could hit a copy plot. That would make it in a cleaner looking plot that you could then save as a MATLAB figure or an SVG or PNG file, so that if you want to make presentation figures out of that. The other thing that you can do is you can export the data from the simulation. So you hit export data from the simulation and save it here. Just overwriting the one that I did previously. Then open that up. You see a whole bunch of numbers. And if you open up this in Excel, you'll see this in a more formatted way. And so that allows you to kind of plot the results of the simulation using whatever software you'd like. Some of the other kind of useful tools here are you could export to Cytoscape for network visualization. That's going to be in another tutorial. Or you can export the math and the code that generates these sort of models using these export MATLAB ODE or export Python ODE files. And so I'm going to do that here. Again, I'm kind of overwriting ones I've done before. And so it's probably most informative to look at the Netflux ODE file. And in this, you can see right here are the 5 differential equations that govern this model. So this is showing most of the math of what changes the protein states in the system, differential equations. And then this shows the math for how we do the sigmoidal activation functions right here. This is showing how we do inhibition reactions, or gate logic, or AND gate logic. Okay, so we kind of did all of these exercise 1 basics, and then we also looked at exporting these various different features that to get useful things out of Netflux. So I'd like you to consider doing some of these others on your own, so just changing various different parameters that affect the result. One thing I'll just show you real quick, we use it a lot, is this. So we changed so far the reaction weights. We don't usually change the Hill coefficient and EC50 very much, but you can. One thing that we change a lot is the Y max. And so if you want to say for species D, you want to knock it out, you would set its Y max value to 1. Or if you want to like overexpress it, you could set it to like 5 or 10, something like this, and then see how that affects what happens in the network. And then some of these other ones that you should consider looking at is you can go ahead and modify the spreadsheets that are provided along with this. to add new reactions and save the changes and then reload the model, see what these new reactions do. One thing, if you're going to make your own network, as shown right here, what I really recommend is that you start with that example network and then edit it, because there are some subtle things about the formatting of that spreadsheet that you might not get otherwise. And then finally, you can design experiments and then test those experiments out to see if the network responds as you predicted. And so one of the most important concepts here is that you make a hypothesis of what should happen, and then you evaluate that in a model. And so if that turns out the way you expected, then that's great. That builds some confidence. But if it's different than what you expected, then it kind of helps you reevaluate your knowledge about that. Okay, well, that's everything we have to show for today. I appreciate you tuning in, and please let us know if there's anything that we could do to help you get started. Thank you.